Ladies and gentlemen, welcome back. So today we're going to start talking about limiting reactants. And a limiting reactant. So the ingredient that is used up first is known as the limiting reactant. So the limiting reactant or limiting reagent is a reactant that limits the amount of product that can be formed. And from yesterday's exit slip, we talked about in the case of a ham and cheese sandwich, the limiting reactant would be the bread. Now, an excess reactant, the ingredient or ingredients that were left over are considered the excess. So the excess reactant, the reactant that's left over after the reaction takes place. So in this case, the excess reactant or reactants are the slices of ham and cheese. So, just not going to be talking about lunch meat sandwiches, but we're going to put this to good use in terms of chemistry. So we see here copper reacts with sulfur to form copper 1 sulfide according to the following balanced chemical equation. So it says, what is the limiting reagent when 80 grams of Cu reacts with 25 grams of sulfur? So we notice here we have two initial values. We have 80 grams Cu and 25 grams 25 grams S. And we have one product, Cu2S. So what we need to do is we need to do two separate stoichiometry problems. And since it doesn't tell us about that it wants us to go to mass, how many grams of Cu2S, we're just going to go to moles to make it easier on ourselves for right now. Now, I'd clearly tell you if there was more than one product, which one to go to, but there's only one, so obviously we're going to Cu2S. So we'll start with 80 grams of Cu times 1 mole of Cu all over 63.55. So we're in our moles of Cu. We're at our easy pass station. Let's go to cross the bridge here. Let's use our mole ratio. So times 1 mole of Cu, 2S, all over 2 moles of Cu. So I calculate this, 80 divided by 63.55, divided by 2, and I get 0.63 moles Cu2S. Now the second one, 25 grams of S times 1 mole of S all over 32 grams of S times 1 mole Cu2S all over 1 mole of S. So we do 25 divided by 32, and we get 0.78 moles of Cu2S. So we want to figure out our limiting reagent or limiting reactant. So what I need to do is I need to look at the values that I came up with for my gram to mole stoichiometry. And I need to determine which number is smaller. So in this case, 0.63 is smaller. So this number is the number of moles produced for Cu2S. And since it's the smaller number, it's limiting the production of our product. And if I look, where did this 0.63 moles of Cu2S come from? Cu. So our limiting reagent would be Cu. Right, so the smaller number will always tell us our limiting reagent. So remember those numbers. So we're going to remember this number, 0.63 moles. Because it'll help us in our next problem. So we don't have to do these calculations again. Okay, so it says, what is the maximum number of grams of Cu2S that can be formed from 80 grams of Cu reacts with 25 grams of S? So we already figured out what our limiting reagent was from the last problem. So I'm going to start with, we know we did 80 grams of Cu times 1 mole of Cu. I'm not going to do both problems. We don't need to do that. We already know what our limiting reagent is. And our molar mass of Cu2S, 159.16 grams of Cu2S. So we have 80 divided by 63.55. Divided by 2 times 159.16. And we get around 100.18 grams of Cu2S. Now, the only reason I did one of these stoichiometric calculations because the slide before, like I said, we already found out what our limiting reagent was, and that was copper. So it says rust forms when iron, oxygen, and water react. The chemical equation for the formation of rust is as follows. So we have 7 grams of iron and 9 grams of water available, which is the limiting reactant. So it doesn't tell us what's the maximum amount of grams, so we'll just go to moles once again, make it easier on ourselves. So we have 7 grams of Fe times 1 mole of Fe all over 55.85 grams of Fe. Now use our mole ratio, so 2 moles FeOH2 all over 2 moles of Fe. Plug this in our calculator, and we get 0.13 moles FeOH2. Next one, we have 9 grams of water times 1 mole of water all over 18.02 grams of H2O. Mole ratio, so 2 moles FeOH2 all over 2 moles of H2O. Plug this in our calculator, and we get 0.5 moles FeOH2. So now, which is the smaller number? And we should all see that our smaller number in this case will be 0.13, and this 0.13 was produced from which reactant? Fe, so our limiting reagent will be Fe. And this concludes our video on limiting reactant.